All right, we're going to continue with our triangles today, and we are going to have triangle inequalities. So, we have triangle ABC here, and the triangle inequality theorem says two sides of the triangle must add up and be greater than the third side. So if I add A and B together, they have to be greater than side C. Okay, so if I add these two together, it has to be longer than side C. Then if I move around, B plus C, these two sides, have to be greater than side A. And if I move around, side A and side C added together have to be bigger than side B. So how do we apply this? Okay, well, we have, are these side lengths a triangle? So I have to test each side. So is 4 plus 7 greater than 10? And you can do mental math, yes. Is 7 plus 10 greater than 4? Yes. Is 4 plus 10 greater than 7? Yes. And you can do mental math on those real quick. So you could label your sides A, B, and C as well and then follow the inequality, but you're taking the first two sides and seeing if it's greater than the third. Then I kind of move down the line. Then I take the next two sides, see if they're greater than the first one. And then the first one and the last one together have to be greater than the middle one. So if I look here at 2, 7, and 9, I need to ask, is 2 plus 7 greater than 9? And the answer is no. Why? Because I get 9 is greater than 9, and that's false. They're equal, but it's not greater. So this would not be a triangle. If any of these turn out false or no, then it is not a triangle. Okay, so another application of this is two sides are given. Find the range of possible lengths for the third side. Okay, so I need to test those side lengths, right? So one of the situations is I'm going to add them. So 8 plus 12, okay, has to be greater than one of the sides C. So 20 has to be greater than C. Okay, then one of the situations, I would have to take 8 plus C, and it has to be greater than 12. Okay, that's one side. So if I subtract 8, C has to be greater than 4. Okay, and in the third situation, I would have 12 plus C has to be greater than 8. And if I subtract 12 from both sides, C would have to be greater than negative 4. The only problem with that is C can't be negative. It's a side length. It has to have a positive value. So this can't be negative, and therefore I can eliminate it. So really what it comes down to is to get the maximum side length, you add the two sides, okay, and to get the minimum, you subtract the two sides. Now I do have to represent this as a range. So my C has to be less than 20 and my C has to be greater than 4. Rewrite it as a compound inequality. So C would be in the middle, and it has to be less than 20 and greater than 4. So this is my range. C has to be less than 20. That's the maximum when I add them together. And C has to be greater than 4. That's the minimum when I subtract them. Okay, so when I'm doing 4 and 12, what's the range? Well, remember, my maximum means I'm going to add them together. So 4 plus 12. Oh, I'm sorry, that's 11.4, not 11.4. Okay, so that's 11.4 plus 12. That gives me 23.4. That's my maximum. My minimum, I would subtract them. 12 minus 11.4. Remember, it can only be positive, so I'm subtracting the bigger number from the smaller number. That gives me 0.6, which means my inequality, I'm going to write C in the middle, has to be less than the maximum, 23.4, but greater than the minimum of 0.6. So this is my range, and it is written as a compound inequality. Okay, so to get the maximum, you add the two sides. To get the minimum, you subtract the two sides. We're writing a compound inequality. The minimum is less than the variable is less than the maximum. Okay, because this piece represented the minimum, this piece represented the maximum. 0.6 represented the minimum, 23.4 represented the maximum. Okay, then we're going to be able to order the sides and angles. Order the sides and angles. So this one says order the angles from least to greatest. There's only one problem. I don't have any angle measures, except for that one. That's a right angle, so I know that one is 90. Maybe that'll be easier. That one is 90. But the rest of them I don't know. So we are ordering them based on the side lengths. Since 3 is circled, I'm going to go with 3. 3 is the least side, and that means that directly across from that is angle Z, and that's going to be my smallest angle. So angle Z is going to be my smallest angle. Okay, so then I got 4 and 5. So the next number from least to greatest is 4. So if I look directly across 4, there's angle X. So angle X is next in line. And then 5 is my biggest number. That's my greatest length. That means directly across from it is angle Y. And it's 90 degrees, and I do know these other two are acute. Okay, so the angle, the order of my angles from least to greatest would start with the shortest side and the angle directly across from it. So ZXY orders my angles from least to greatest. Then we have vice versa. Order the sides from least to greatest, except for one problem. I don't have any side lengths. I do have the angle measures though, and 29 is circled because it's my smallest angle measure, and vice versa. I'm going to look directly across from 29 and I see this segment ST. That means ST is my shortest segment. And I'm using the notation we learned in Unit 1 with the segment piece above it. My next angle measure is 30. So directly across from angle 30, I see this segment RS. That would be my next longest piece. And then we have 121. That's the biggest angle. That means directly across from it at the bottom here, RT is my longest side. Okay, so we can order the sides and angles based off of their counterparts. Okay, now it's your turn to practice.